Hello friends, welcome back to your UPSC. Today we'll start with another topic of geomorphology, that is earthquake. So let's get started. Earthquake. It is a sudden or catastrophic release of strain of energy stored in rocks around the fault. Okay? So it is a sudden release of energy whenever the rocks move or pass each other. So the sudden release of energy which uh, which is caused due to catastrophic movement of the rocks due to fault, they lead to earthquake. Okay, so the earthquake is having following characteristics. First, it generates waves that travel through the earth. So in seismology we have read that the waves that are generated are P waves, S waves and L waves. Okay, so these are the waves that are generated and they pass through earth. Okay, so these both, they don't go in the, they don't pass, they don't move in surface of the earth. Okay, this is only the surface wave, and these two, they pass through interior of the earth. Okay, now second is, earthquake mainly occurs when the rock slips through or along the fault. Okay, so either there is conservative movement or constructive movement or destructive movement, that times fault occurs. Okay, now there are some basic terminologies related to earthquake which we should know. So the first one is focus. Focus, here you can see focus. So the focus is the main point of the origin of earth. Here is where the rocks that moves. Okay, so here is where the main thing takes place and the main point of occurrence of earthquake. Okay, and second is our epicenter. It is a point on the earth's surface laying directly above the center of the earth, the center of the, sorry, the focus. See this. So, here we have our focus, and the area that is laying directly above this, okay, on the surface, is our epicenter. Okay, now the third is our surface waves. First we will see what are body waves. Body waves are actually the waves that are starting from the focus. Okay, they move towards the earth's surface. They start from the focus and they move towards the earth's surface. So these body waves are P waves, S wave and L waves. P waves, they are the waves of highest velocity, as we know that, and they are longitudinal waves. S waves are the are having the medium velocity. Okay, they are having the velocity less than P waves but more than L waves. They are transverse in nature. Okay, and then we have L wave, which is surface wave. Okay, that is actually the main cause of earthquake, because this is the only wave which moves on the surface. Okay, so we have body waves, which are P wave, S wave and L waves, and then we have surface waves, the waves that finally occur on earth's surface. Okay, they are surface waves. Okay, next two terminologies are, first is isoseismic line. What are isoseismic lines? Isoseismic lines are the lines, like we have contour lines, etc. So isoseismic lines are the lines which join the points or the places which are having which are having the earthquake, or which have experienced the earthquake of equal intensity. Like if this area have experienced the earthquake of 8 at the Richter scale, this also and this also. Okay, so they are having equal intensity, so they are, the line joining these three places will be isoseismic line. And what are homoseismic lines? Homoseismic lines are the line which join the areas which have experienced earthquake at the same time. So the intensity is not same, intensity may be same or may not be same, but they have experienced the earthquake at the same time. Like if this one has experienced earthquake at 9 o'clock, then this one is will also be experiencing the earthquake at 9 o'clock in the morning, and this one also in 9 o'clock in the morning. Okay, so the time is same, and in this intensity is same. Now we will look into the causes of the earthquake. Okay, so the basic causes of the earthquake are stress and strain, and we can't say that stress, either the stress occur first or the strain occur first. Okay, so what exactly is stress? Stress is, see, there are two plates which pass each other, okay, or which move past each other. They actually cause stress. Okay, so the force into area is stress, and stress may lead to four type of deformation. First is first is plastic deformation. In plastic deformation, earthquake does not occur. Okay, so it is like it deforms and then it gets back. Second is elastic deformation. Elastic deformation, the rock actually stretches. It keeps on stretching, and in the physics we have read that when a thing, elasticity of the thing lies to a certain extent, and then it reaches to the breaking point where the rock fractures. Okay, so here in this case the rock fractures, and this causes the release of energy which leads to earthquake. Just a second. So this leads to earthquake. Next is flow. Now, stress in flow, it has a viscous behavior, and fracture. Flow, then fracture. Fracture is like when the solid rocks, they are having brittle behavior, they just break. Okay, and this breaking leads to release of energy which causes earthquake. And the second one is strain. Okay, strain is deformation in a solid included by applied stress. Okay, so it is deformation in any solid, like I have a rubber band and I will stretch it. Okay, so when I will keep on stretching it, like first it was like this size, then when I keep on using it and stretching it, it will increase. Okay, so losing its original property, it stretches. Okay, and this strain is dimensionless. Okay, so they both occur simultaneously. uh, Stress can occur first, or strain can occur first, and then stress can occur, then strain can occur, so they occur one by one. Okay, one after the other. Next is plate tectonics. So plate tectonics we have studied in detail, so I will not go in details. I will just quickly revise it. So we have three types of plate boundaries. Okay, first is divergent plate boundaries, second is convergent plate boundaries, and third is transform boundaries or slip boundaries. Okay, they are conservative plate boundaries also. So in divergent plate boundaries, what happens? The plate moves against each other. In convergent plate boundaries, they move towards each other, and in conservative they move past each other. Okay, so divergent plate boundaries, simple example is mid oceanic belt. Okay, and in conservative is Andreas Saint Andreas fault, and conservative plate boundaries is mid continental belt. Okay, mid continental belt is that one in Himalayas. We will study it, okay, in examples or distribution of earthquake. Sorry. Now, so we have studied volcanic activities also. So volcanic activities, like we have volcanic belt. Okay, we have volcanic belt like Pacific belt, ring of fire. Okay, here also the plate moves, causing the earthquake to occur, and at the same time volcanoes also occur. Okay, next is anthropogenic factor. Anthropogenic factor are actually like when we build dam, the sometimes the crust actually it becomes weak, leading to fracture of rock, and thus leads to release of energy and causing earthquake. Okay, so there are various anthropogenic factors also. Next is crustal contraction. Actually, in crustal contraction, what happens is, due to some temperature changes or change in equilibrium, the crust of the earth, it either contracts or it either contracts or it expands, because of which there is release of energy which causes earthquake. Now next we have impacts of earthquake. We have two type of impacts of earthquake. First is geographical and second is economic. So in geographical we have like landslide. Whenever earthquake occur, if the area is very loose, so the area here, okay, or the sand here or the land here will slide down. Okay, this mainly happens in hilly areas. Next is flood. So in when the river flows during earthquake, either the water level rises up. Because of the rise in water level, the flood occurs, and water levels also sometimes goes down. And the second is rise in rising and lowering of sea floor. Okay, so due to earthquake, there is breaking of crust. Okay, so either the sea floor rises or it comes down, lowers down. Same things happen with the coast. Next is fault formation. Okay, there is breaking up of rock, and due to this breaking up of rock, faults are formed. Tsunami is also caused due to one of the cause of tsunami is earthquake. We have studied it in plate tectonics. Next is displacement of the crust. Okay, so due to, see, these are conservative forces or any type of forces. So the crust is moving either apart or towards each other, or they are moving past each other. Okay, sorry. Next is economics. Economic cause. Now, what are the economic impacts on of the earthquake? So the cultural landscape. So what are the cultural landscape, like buildings, loss of building, damage of cultural landscape? In it we have loss of buildings, pipelines, gas lines, because of which fire occurs. So there is devastating devastation of cities. Okay, and there is huge loss of damage of life and property if not early mitigation happens. Okay, next is how can we, so first, before studying earthquake management, we will quickly see the distribution of earthquake. So in distribution of earthquake, we have, first is circum-Pacific belt. Just a second. We have circum-Pacific belt. So this area of the Pacific region, here and here. Okay. So this is circum-Pacific belt. Okay. So circum-Pacific belt, it covers like 68% of area of earthquake prone region. Okay, in both side. Okay, next is mid-continental belt. I was the one which I was talking about. It ranges from here to here. Okay, it covers 21% of area of earthquake prone region. This is mid-continental belt. Okay, next we have mid-Atlantic ridge. Here we have mid-Atlantic ridge running from North Pole to South Pole in Atlantic Ocean. Okay, this is mid-Atlantic ridge. And next we have, last one is Gulf of Aden. Okay, this is Gulf of Aden. Okay, So these are the major four region where the where we have major earthquake prone region. Okay, so this is our divergent plate boundary is mid-oceanic belt. Okay, mid-oceanic belt, divergent plate boundary. Then we have convergent plate boundaries is St. Andreas Fault, and then we have transform boundaries here, this one. Okay, now we will quickly look into earthquake management. So in earthquake management, what we can do first is early warning. So if the people uh, come to know about, like early, if they come to know about that earthquake is going to happen or something, like some disaster is going to happen, so they can rescue from this destruction. Second is earthquake resistant building. The best example is Japanese building style. So earthquake resistant building can help in earthquake management, as there would be less damage to life and property. Third is long term production. Fourth is expertise training. So in an earthquake prone region where the earthquake frequently occurs, the expertise or experts can train people how to mitigate from this disaster. Okay. Then fifth is 3 hours. 3 hours are rescue. Firstly, we have to rescue these people from this disaster prone area. Next is giving them relief and rehabilitating them into another safer area. So these are 3 hours. And sixth is coordination among authorities. So these 3 hours can be followed when the local authorities coordinate with people, or the people coordinate with local authorities. So this is how we can manage, we can quickly manage, or we can easily manage earthquake. Okay, disaster from earthquake, because it is not the earthquake that damages life and property, it is the buildings and all that things that damages life and property. Okay, it is our cultural landscape that is damaging it. So now with this we come to the end of our lecture, that is earthquake. So that was all for today, guys. I hope you enjoyed the class. So let's meet in our next lecture. Till then, take care and have a nice day.